Welcome to the Project Management Prepcast, the direct route to PMP exam success. Here's your instructor, Cornelius Fichtner.
Hello and welcome back to the Project Management Prepcast, where we take complex project management concepts and make them look simple. I'm your instructor, Cornelius Fichtner. In this lesson, we are going to take a look at the decision tree and expected monetary value tools and techniques from project risk management. We discuss the concept of mutual exclusivity. We create and analyze a decision tree, explaining each step in the process, and at the same time we'll cover expected monetary value and what it is and how to determine it, and finally we talk about the benefits of the decision tree and how to combine it with the expected monetary value. And to put everything into context, here are the 6 processes from project risk management. The decision tree and expected monetary value are modeling techniques from the perform quantitative risk analysis process. Why are they in quantitative and not in qualitative? Simple, because they both enable you to assign a value, a number, a quantity to our risks. So let's compare the decision tree as well as the expected monetary value here in our quick overview. The decision tree analysis is defined in the PMBOK guide as a diagramming and calculating technique for evaluating the implications of a chain of multiple options in the presence of uncertainty. The decision tree is a diagram that describes a decision under consideration and the implications of choosing one or another of the available alternatives. It is used when some future scenario or outcome of actions are uncertain. It incorporates probabilities and the costs or rewards of each logical path of events and future decisions, and it uses expected monetary value analysis to help the organization identify the relative value of these alternative actions. And that's important. The decision tree uses the expected monetary value analysis. It's included in it, usually. So the expected monetary value analysis then is defined in the PMBOK guide as a statistical technique that calculates the average outcome when the future includes a scenario that may or may not happen. It helps to calculate the average income and expense, and it helps by incorporating future scenarios that may or may not happen. Let's take a look at the details. But before we can look at the decision tree diagram, we first have to discuss what is known as mutual exclusivity. Don't worry, it's a very simple concept to understand, I promise. For instance, the motor of your car is either on or off. A glass is either empty or not empty. A fire is either burning or not burning, and you will either succeed or you will not succeed in a particular event. One state excludes the other. If we factor percentages into this, then this percent always adds up to 100. For instance, the motor of your car is on 30% of the time and it is off 70% of the time. The glass is empty 80% of the time. It's full 20% of the time. The fire is burning 10% of the time, not burning 90% of the time. And you will succeed in the event 55% of the time, and you will fail 45% of the time. This also works with decimals. The probability that the glass is empty is 0.8. The probability that you will succeed in the event is 0.55. And as I promised, you can see it's a very simple concept, and that is all that is needed here in regards from the mutual exclusivity to understand as part of the basics of decision tree analysis. Let's now take a look at a basic decision tree diagram. Here it is. It consists of boxes, lines that connect the boxes, and nodes. In regards to these nodes, there are three types of nodes. First of all, we have the decision nodes. They're commonly represented by squares. In our drawings here, that is the red square over in the left-hand side. Then we have the chance nodes, usually represented by circles. Here we have orange circles in our drawings. And lastly, we have the end nodes on the very right-hand side, represented by green triangles for our examples. Of course, these colors are just so that you can see them better. Don't expect these colors to show up on a PMP exam sample question. That includes a decision tree. Let me give you a few more words about this here. Decision trees are always drawn from left to right. You always start with the problem, with the decision you have to make. It is important to note that a decision tree has only burst nodes, and by burst nodes we mean that paths are always splitting. There are no sync nodes. There are no paths that have first split and then will converge again into the same paths. No, paths, they will only split, they only burst. Therefore, if you draw a manual decision tree and you have 10 or 20 decisions with 10 or 20 chances, these trees, they can grow big, big, big. So it's very often difficult to draw these by hand. On sample PMP exam questions, however, you can expect to see a decision tree of about the same complexity as our example here. When we looked at the mutual exclusivity, we only talked about percentages a moment ago. We said that we had a 55% success rate and a 45% failure rate in a particular event. But now let's go ahead and add money to these percentages, because if you could somehow determine precisely what income you could create as a result of selecting one project over another project or one option over another option, you could then select the best one, simply by choosing it based on the highest value. And that would mean what you have just done is you have chosen the option with the highest expected monetary value. You've chosen the option with the highest income that is created for you. Let me give you an example here with cards. So let's assume I have a deck of playing cards here and you are going to draw cards from me. If you draw a red card, you will get 10 euros from me. But if you draw a black card, you will get nothing. For you, it's now easy to see you want to choose the option red because you want to earn those 10 euros. The chance of you drawing a red card or a black card is, of course, always 50-50. So you have a 50% chance of winning 10 euros and you have a 50% chance of winning nothing. Now let's show this situation in a decision tree. And here is the situation with the playing cards drawn as a finished decision tree. I drew this decision tree first by drawing the boxes, the lines and the nodes from the left to the right, and then by adding the numbers in blue, the euro values, from right to left. So let me walk you through how I did this. First, I drew the card game box on the very left. I said, okay, out of the card game box, I have a chance node. That is the orange circle. And the chances are that I can either draw red or black. So I drew those 2 boxes there. And because this is a 50-50 chance, I added 50% at the top for drawing red, and I added 50% at the bottom for drawing black. And then I added an end note, the green triangle at the very right. Okay. Now I have the boxes and the lines and the notes. Next I went ahead and I added the values in euro. 10 euro I will receive if I draw red, 0 euros if I draw black. So I added those to the very right, just behind the endnotes. And now I calculated my way backwards from right to the left. I know I have a 50% chance to draw red. 50% of 10 euros is 5 euros. I also know I have a 50% chance to draw black, but of course 50% of 0 euros is still 0 euros. And then I looked at those 2 chances and I added them up. 5 euros and 0 euros is 5 euros, and these 5 euro total of my 2 chances was added on the left hand side right there to the left of our chance node. 5 euros went there. This is a very simple example, a simple overview of a decision tree. Let's now go ahead and make a somewhat more elaborate example and go through it step by step. And for our example, we are going to hold a tennis tournament. And luckily, we have some historical numbers. The ticket prices, for example, we know that we can charge £110 for indoor tennis tournament tickets, and we can charge £105 for outdoor. We also know historically that we have a chance of rain of 40%. We also have the historical attendee numbers. We know that if it's outdoor and it rains, we have about 2,000 attendees. If it's indoor with rain, 3,500. If it's outdoor with sunshine, we have 5,000 people. And if it's indoor with sunshine, we have 4,000 people, because who wants to go to an indoor tennis tournament if the sun shines? Your job now is to make as much money as possible from this tournament. This means that you will want to hold this tournament in such a way that you select the option in which we receive the biggest chance for the biggest income. You can either hold an indoor or an outdoor tournament, and the question is, which one will bring you more money? The decision tree will be based on mathematics and on the expected results from our chance events. So you will use the decision tree and expected monetary value in combination to figure this out. And step 1 in figuring this out is we have to create our basic decision tree. Here it is. What you see on this is that we have used the concept of mutual exclusivity on the right there with the endnotes. The variables that were given only said that there is a 40% chance of rain, and by applying logic and mutual exclusivity, we know that therefore the chance of sunshine is 60%. So what I have drawn here for you is the tennis tournament on the very left, then our 2 options, the option nodes. We can either have this as an indoor or an outdoor tennis tournament, and in each case we have a chance node, that's the orange circle. It can either be raining or the sun could be shining, and we know that the rain has a 40% chance, therefore sunshine has a 60% chance, and we have the green nodes at the very end. Of course, this is totally oversimplified for our example here, because if we have a 40% chance of rain, well, there could also be a 10% chance of fog, a 15% chance of drizzle, a 6% chance of heavy rainfall, and then we would only have a 29% chance of sunshine left. But let's keep the example simple here. Next, we're going to move forward, and let's add the spectator numbers and our income to this example. And to calculate our income, we are simply going to be using a spreadsheet application or a table like this one here. We'll fill in the conditions, the spectator numbers, the ticket price, and we multiply these with each other, and we end up with an expected income on the ride based on our current ticket prices and the historical numbers of attendees that we can expect if we have an outdoor with rain or an indoor with rain or an indoor with sun tennis tournament. All the combinations that we need in order to fill in these numbers into our decision tree are now here. Okay, so let's fill the numbers into our decision tree as our next step. And what I've done for you here is I have zoomed into just one of our 4 branches. This is the branch at the very top right. This is indoor with rain. And as you can see, we have added the calculated income of £385,000 to the right of the green triangle, which is our end note. This now indicates how much income we would generate if we hold the tournament indoors and it rained, based on our calculations from the spreadsheet. But in order to decide between all 4 available options, we also have to factor in the probability of rain or sunshine. And in this case here, of course, it is a 40% chance of rain. This means that there really is only a 40% chance that we will make £385,000 as our income. And of course then, 40% of 385,000 is 154, and that is the number that we added below the percentage. This now indicates that 154,000 is what we can expect as income if we factor the probability of rain into our calculations. This is our expected monetary value for this particular option. So let's move forward and fill in all the numbers on the right-hand side of our decision tree. Here you go. We have filled in all the calculated income numbers to the right of our green end nodes, and then we took that income and we factored in the percentages of rain and sunshine, and then calculated the expected monetary value for all our 4 options and put that number underneath the percentages. Now remember, the top 2 boxes, rain and sunshine, those are the ones that are connected to our indoor tournament, and the 2 rain and sunshine boxes at the bottom, those are the ones that are connected to our outdoor tournament. Next, we are going to add up these outcomes to see which one we should go with. If we add the top 2 numbers, 154 and 264, we get £418,000. And likewise, if we add up the bottom 2 numbers of 84,000 and 315,000, we end up with 399,000. These 2 calculated numbers, these are the numbers that we now move left in our decision tree. And what you see here is the very left of our decision tree. I have gone ahead and I've calculated those numbers again. I've moved them over. At the top, the total is 418,000 expected monetary value for indoor, and below for the outdoor we have 399,000 as the expected monetary value for our outdoor option. And of course, we can now let the numbers speak for themselves, and anyone can see that 418,000 at the top, the indoor tournament, is the bigger number. Therefore, our better option, and this is the number we move over below the tennis tournament, is the 418,000. That is our best option in regards to the tennis tournament. And here you now see the complete decision tree. There's one final word about this. You have to remember that the 418,000 that we put there underneath the final decision, that is only the expected monetary value. This represents our best option for this tournament if we factor indoor and outdoor as well as rain and sunshine and any other conditions that we may also be considering into this. This is not our budgeted income. This just helps us to decide which one to take. It helps us to decide which ones of the many branches that this decision tree may have. Okay, this one only has 4 branches in the end, but imagine a much larger decision tree. Which one of these branches offers the best option for us to maximize our income? The budgeted income for our tournament is still the £440,000 that we have there as the second option for a indoor tournament if the sun shines on the far right. This is the income that we will get if we hold that tournament and the sun shines. Does all of this sound way too complex for you? Well, I have 2 exam tricks for you. And the first trick is you need to focus. When you come across PMP exam sample questions with decision trees and expected monetary value, then occasionally you get questions like this one here. How much is the expected monetary value if we hold the tennis tournament outdoor and it rains? In a case like this, you don't have to draw the complete decision tree. All you have to do is figure out that one single number and nothing else. Remember, you only have 1.2 minutes for each of the questions on the real exam. So focus on what the question really asks and don't waste your time drawing a nice decision tree if you don't need it. Only zoom in to that particular portion of the decision tree which is really needed and calculate that one. The second exam trick I have for you is the fact that there is no rule that says that you have to use a decision tree or draw one in order to figure out the answer to any PMP exam sample questions. You might as well use a table. You're not going to hand in your decision tree and be judged on your artistic merit. Instead, you're going to have to say A, B, C, or D is correct. Personally, I prefer to work out these kind of puzzles in a table format. I find this to be much quicker, much more structured, and I can see the logical flow from left to right. Of course, this only works for simple decision trees, but that is the kind of decision tree that we have to deal with on the exam. So consider using a straightforward table to figure out questions when it comes to decision trees. Let me close this lesson with a look at the benefits of the decision tree, because there are a number of them. First of all, they are simple to understand and interpret. People are able to understand decision tree models after just a very brief explanation. They have a value even with little hard data. Important insights can be generated based on experts describing a situation, its alternatives, probabilities, and costs, and their preferences for outcomes. Decision trees also use a white box model. In a given situation where a specific result is provided by the decision tree, the explanation for the result can easily be replicated by math. This is not a black box where you input some data and at the end a number comes out and you have no idea how this number was generated. No. You can easily follow along and calculate this yourself. It's a white box. Of course, it can be combined with other decision-making techniques like PERT, for example, and as we have done in our lesson here, you can include expected monetary value information into a decision tree as well. And this concludes our look at the decision tree and the expected monetary value. But before we go, I have an exam tip for you that has nothing to do with the decision tree or the EMV. It is a statement that I have received from one of our Prepcast students. His name is Bernd Töpfer, and here is what he wrote. Die Frage, ob man sämtliche ITTOs auswendig können sollte, möchte ich ganz klar mit Nein beantworten. Mit einem grundlegenden Verständnis der Prozesse kann man die allermeisten Fragen zu den ITTOs durchaus beantworten. And for all those of you who don't speak German, here is my translation of what Bernd said. I answer the question, do you have to know all the ITTOs by heart with a resounding no? If you have a good understanding of the processes, you will be quite able to answer most ITTO-related questions. And I could not agree more. This is the argument that I have personally made to all of my students. So let me repeat it again. Don't worry too much about memorizing the ITTOs in the PMBOK guide. Instead, understand what the process is trying to do. That will not only help you figure out the ITTOs for each process, but most importantly, it will make you a better project manager. And this concludes our look at the decision tree and expected monetary value. So it's time for Justine to say,
Tally-ho!
And of course I say, until next time.